Hello friends, in physics class today, we'll be talking about electromagnetic induction. Now the question is, what is electromagnetic induction? Electromagnetic induction is the production of electric current or voltage when there is relative motion between a magnet or a magnetic field and a coil. And we are going to demonstrate that today. So you know what a coil is. A coil is just a wire wound around a cylindrical object. So that is what you call a coil, or you can also call it an inductor. But the question you might want to ask me is, what is an inductor? An inductor is a device which stores electrical energy in form of magnetic field. But now let's go back to what we said. We said that electromagnetic induction is the production of electric current or voltage when there is relative motion between a magnet and a coil. And we are going to demonstrate that today. This is a bad magnet of a strong magnetic field. This is a coil connected to a load or a bulb. Now you will notice that if I move the magnet relatively in relative motion to the coil, what electric current is produced without contact. That is why it is called electromagnetic induction. There is no contact. So let's see. Look at this. You can see there is production of electric current or voltage because there is relative motion. Because there is relative motion. If I change the polarity of the magnet, there is also production of what? Electric current. Look at, you can see there is north pole, south pole. Let's change the polarity. You can see there is south pole very close to the coil now. If you move it close again, you can see. What if I increase the numbers of the coil? What if I increase the numbers of coil? So we have two coils now. Now you see there is what we call what physics here. Now I think you might want to ask a question. What will happen if I move this magnet towards the second coil, demonstrating what you had the other time? You can see. But look at it. Look at the intensity of the light. But look at the intensity of the light here for this. Now, why is this so? It's because the electric current produced depends on the number of what? Turns of the coil. You can see that the turns of the coil here is more than the turns of the coils here. It also depends on the speed of the magnet. The speed of the magnet. It also depends on the soft core, the soft iron core. It also depends on the soft iron core. I would like to show us another thing today. Let me introduce a voltmeter for us to see the voltage so that you know that there is voltage. Let me also introduce the field lines or the flux lines. These are what we call the field lines. These are what is interacting with the coil, producing the current. So you can see the field lines, you can see the voltmeter. The voltmeter measure the electric voltage, the induced EMF or the induced voltage in the coil. So look at it. You can see that the pointer deflects. You can see. So it's measuring the voltage. I also want to show us another thing when we talk about electromagnetic induction. There's something we call Faraday's law of electromagnetic induction. Michael Faraday was a brilliant man. He gave us a law about this. He said when there is relative motion between a magnetic line of force and a coil, he said an EMF is induced, which is proportional to the rate of flux producing it. I will take it again, but in simpler terms now. He says when there is relative motion between a magnet and a coil, he said EMF, electromotive force, is produced or induced, and the strength of that EMF is proportional to the motion producing it, to the motion of the magnet or the coil producing it, which I'm going to show for us today. Now you can see that look at it, when the motion, if the speed is, the value of the speed is small. What can you see here? You can see that the pointer, the movement is also slow, right? But you can see that when I move the pointer, when I move the magnet very fast, you can see the pointer of the voltmeter. So this is what Faraday says. Another thing I want to show us today is also another demonstration of Faraday using the same principle. Now look at this. This is a bar magnet, and this is a compass. This is just an addition to what we've learned today. You can see that when I move the magnet to the close to the compass, what can you see? The pointer of the compass is drawn towards the magnet. If I move it to the other side, what happens? It changes. Why? Because the south pole, it changes. So this is also telling you how the magnetic line of flux operates. You can see these are the magnetic line of force. These things that you can see here are the magnetic line of force. Thank you for attending the physics class today. I have the following questions for you as assignment. State the factors that affect the EMF induced in a coil. On that topic that we just discussed. Number 2, state Lenz's law of electromagnetic induction. Thank you.